In general, the moment equilibrium equation is a vector equation. However, for 2D problems, it simplifies to a scalar equation in terms of the moments of the forces about a point in the plane. We write the simplified equation as sigma mp equals 0, where p is the point about which moments are computed.
When constructing a moment equation, care must be taken to find a suitable reference point for the moments. It is typically best to choose a point that eliminates most unknowns. To illustrate, let's consider taking moments about point C. Before we start, we take a look at the designation of positive direction for the moment. By convention, we set the counterclockwise rotation as the positive direction. As you will see later, this step is crucial in identifying the plus and minus of the moment terms that are about to come. Here, in the first case, because Cx and Cy pass through the point C, they do not produce a moment about C. For force B, it does produce a moment about point C. The perpendicular distance, L1, between point C and force B is called the moment arm for that force. Although force B is a negative force pointing down, it nevertheless generates a counterclockwise rotation regarding the point C, and since counterclockwise is the designated positive direction for a moment, we call the resulting moment term a positive one, which is why we obtain the plus B times L1. Likewise, forces AX and AY produce moments about point C. Force AX generates a clockwise rotation regarding point C. Therefore, it creates a negative moment about C, that is, negative AX times L2. As for AY, it also generates a clockwise rotation with respect to point C, thus creating a negative moment term, and that is negative AY times L3. After obtaining all terms for the equation, and assuming that all length parameters are provided in the problem description, we see that our moment equation has three unknowns, b, ax, and ay. Since we only have one equation available, it is rather difficult for us to solve for the unknowns. Now consider taking moments about point B. For Cx and Cy, they both generate moments about B. Ax and Ay also generate two moments about B. Because Cx and Cy are known, we now have two unknowns in the equation. Finally, consider taking moments about point A. Forces Cx and Cy both generate moments about A. Force B also generates a moment about point A. Since Cx and Cy are known, we now have only one single unknown, the force B. This equation is particularly useful because it can be used directly to determine the force B, which afterward allows us to solve for the rest of the unknowns. We need only one moment equation. As we have seen, we have a choice about which point to take moments about. For this problem, the best choice is to take moments about point A so that we obtain an equation that can be easily solved.